Hi, everyone. I'm Jim Cahill, and welcome to this Emerson Automation Experts podcast. Emissions mitigation remains a major challenge for oil and gas producers. I'm joined today by Manuel Arroyo and Stan Calame to discuss ways that technology is helping in these mitigation efforts. We'll dive into some of the issues and how they are being solved. Many of the things we will discuss have been captured in a new white paper developed by the oil and gas industry team. Welcome, Manuel and Stan.
Well, morning.
Hey, great having you joining us today. So I guess, Manuel, let's dive right in. What inspired the creation of the white paper, and what gap in industry knowledge or practice were you aiming to address?
Thank you for that question, Jim. I mean, there are so many different reasons that inspired Stan, myself, and some other members of the team to write this paper. So the first one, there are new regulations that they were recently approved, but the new administration is changing the course of those new regulations. So there are new areas that have been targeted, and there is a lot of questions about how you can tackle this, how you can do this, how you can do the other. And then on the other hand, we have seen a lot of new technologies available and be present for just monitoring and look at where the emissions are, trying to quantify those emissions, so on and so forth, but not really much focus on mitigation. That is the end goal. At the end, what we don't want to is increase those emissions, is just mitigate. So that's what this paper is focused on, those different technologies that they go and tackle and mitigate from the source and how to prevent those emissions. So that's basically, it is not a gap of knowledge, it is just a gap on the focus, on the main focus on this, that for us, it is mitigation more than just monitoring.
Okay, yeah, that makes a lot of sense. Now, I noticed in the paper that it's at 75% of methane emissions occur at production sites. What are the most overlooked sources of these emissions, and why do they persist despite ongoing mitigation efforts?
Yeah, that's another good question, or questions, if you will, right? The number seems to be high. That's for sure. But we need to consider that that's where the gas is produced, right? That's where everybody should expect the most amount of emissions, or the main source of emissions. So 75% seems to be extremely high, but it's extremely important to highlight what the industry has been able to do. They reduce 13% emissions or methane emissions on the gas, even that the gas production increased 101%. And the oil production increased 53% in between 2005 and 2021. So it is a huge improvement from the industry, even that the production increased. So that balance that emission reduction effort and the production cost. So it is a huge improvement. Yeah, the number seems to be high, but we need to highlight what the industry has been able to do. Answer the second part of the question. If we look into the EPA greenhouse gas reporting, it is extremely clear that the main source of methane emissions is the pneumatic devices. And this is just followed by some equipment leaks. But pneumatic devices is the main area or source of emissions for methane.
Yeah, I would add also, Jim, just from a personal observational standpoint, for example, in West Texas, which is very remote and distant, over the last probably over the last 10 years, you've seen an increase in purchased power used versus natural gas. The reason gas was used in the first place to operate the devices because that's all they had. And there was no power, literally. And so now you've seen a huge electrification to the oil field in general. I don't know if that's the case across all basins, but certainly in the Permian Basin, electrification has helped. So I think that's worth consideration.
Yeah, I cut my teeth in the oil and gas industry when I started my career back in the mid 80s. And basically all you had was pneumatic devices in control of everything. So I imagine the emissions back then, today, they're much, much lower than what it was back then. I guess, can you explain the role of pneumatic devices in upstream emissions and why they're considered one of the largest contributors, and what alternatives are proving most effective?
Absolutely, I can start with that. So, Stan already mentioned that, right? Majority of the production facilities, well pads are remote located. So those areas, they have no access or limited access to power. So the solutions back in the days, as you said, in the 80s or even before that, it was pneumatic devices and use the power of the natural gas, that it was a secondary product on the production, because we were looking for oil at that moment mainly. So gas, it was a subproduct that it was even released or put it into the flare. So it was a really good solution to use that power to power the devices and being able to control the places, right? That has been evolved as well. So now we have a low bleed devices. They release the least amount of gas. All that happened in the last 10, 15 years, right? So that's basically the main source. Every single time that a controller has to control level or pressure, or the valve needs to open or close, every single movement, it releases gas to the atmosphere. As I said, there are new devices that they are low bleed devices now. But they continue bleeding, right? They continue sending this amount of gas to the atmosphere. So that's the power of the pneumatic devices. But then there is the other side of that situation. So the bleeding portion. There are several different alternatives now. So Stan again mentioned one of them is bringing electric power into the facility. So one of them is electrifying the well pad, that is called. So basically change all those pneumatic devices for electronic based devices. That is basically zero emission devices, right? The other option that we are seeing as well, it is, instead to use natural gas, it is using pressurized air to control that. So with the same philosophy of bringing power, now is bringing that air compressor into the field to produce that compressed air and put it into those pneumatic devices. So you don't change the pneumatic device, but now you are not using natural gas. Those are the two main things. So there are ways to take decisions based on budget constraints and process conditions, user requirements, so on and so forth, that you are going to decide in between, or keeping your pneumatic controllers and just do a upgrade and being able to use those with air, or make a different type of investment and really consider zero emission devices that are electric controllers and actuators, and go with that. Stan, I don't know if you have any other comment on this.
I agree with what you're saying, and we've seen more producers start considering just electronic control of the final electronic level, and then electronic valve control, and so that's a different paradigm for operators who are used to just dealing with pneumatic devices, and that takes automation. So not all producers can afford to do that, but we certainly have seen that trend on the large multi-well facilities, especially where they can concentrate that capital and get a high return on that investment.
Yeah, it seems like if it's an existing facility that's just filled with pneumatics, where electrification happens, then yeah, air compressor skids, motor, you got the motors driving your compressors and then switching from natural gas in there. And for newer facilities or new well pads going in or something, considering, just going with electric actuators and everything else and avoiding all the pneumatics and everything in the first place.
Right. And another trend that you see is, where in the past customers may have sort of dealt with the consequences of process upsets and, resulting in flaring. Now, if they are sensing that and they're actually actuating a choke, an automated choke on the wellhead. So, turning back production so that the production equipment can catch up, so to speak, and so that you go back to the source, which is the wellhead. And if you throttle back, that has to be balanced with, obviously you're throttling your revenue stream, but there's a safety aspect, and also if you throttle it back, you're not losing that gas to flare and emissions. You're being able to monetize that maybe at a little later date. But I would say my observation, from the previous administration, the restrictions or the regulations, I think it sort of woke up the industry, and probably even before the last administration. But I think what I see is producers have realized that every molecule that I can capture and monetize, not only am I not emitting it, but I'm getting paid for it. So that makes a lot of sense when you're reporting to shareholders, I think.
Yeah, I think that's a great point. And it points to, what automation can do to help with that, to make sure, it's not going to flare, that you're capturing it and it's part of your revenue stream as you're getting it into the pipelines. So you discuss the challenges of valve maintenance extensively. So what innovations in valve design or monitoring are helping reduce fugitive emissions most significantly?
Well, Jim, in general, for the industry, there are different ways to achieve a goal, right? So sometimes we said, if you want to reach Rome, Italy, you can have different ways to get there, right? So there are different ways to solve this problem, to approach these different challenges. There are different vendors out there with different approaches to the same challenge. What we do at Emerson, we combine two things. We combine the remote monitoring strategies with a new design, especially on the packing, where they'll leave load spring to maintain consistent and constant pressure. So that allows to reduce the emissions without really constraining the stem movement. So that combination, it is the new design on this packing system. It helps us to support our operators' strategies to reduce emissions. So that combination is what we are doing. But as I said, there are different approaches from different vendors.
Yeah, I've written about like the environment, or what is EnviroSeal packing as ways to really reduce what the valves are emitting there. So yes. Technology has come a long way to help us there. Stan, let me throw this one your way. How do newer technologies like tankless emission control treaters and pressurized hatchless vessels change the game in emissions mitigation? Are they scalable across different types of well sites?
That's a great question, and one that I'm not sure I can totally answer, but I think in some cases, the real answer is probably to be determined. I think there's lots of producers that are trying that. The real challenge is that you don't have much of a buffer because you're going typically from these pressurized vessels directly to sales. So if you have process upsets, your only choice is to curtail production because there's no room, there's no volume in tanks to stack that oil up and or water. So, but we are seeing greater adoption of that. It's more challenging. So I think, at the same time, we had an example of a customer who was, they were concerned with trying to actually detect when they might have emissions from the tank. And so they deployed one of our devices, the FBX Edge, which is an industrial PC and a software stack that enables us to connect multiple devices and perform some machine learning activity. And what they discovered is that, even whenever they were in the process of trying to mitigate the emissions, they also solved for pulling in excess oxygen into these tanks, whenever they would pump out of the tanks. So it was a little serendipitous there, but I think it just shows where the technology is going. I think it'll continue to be a challenge. I think the tankless designs will continue to be implemented, and I think they'll evolve over time. So I would say we're probably still in the learning curve. As an instrument person, I can't speak, for the producer, but that's my general feel, if that answers your question.
Yeah, I think it does. And that sounds like a real challenge, that really not having that buffer capacity to deal with, upsets and whatever happens in there. So I can see, maybe as more AI comes along to be able to, predict that, whatever else, and deal with it a little better. So, I think there's.
In thinking about that, this occurred to me a couple of weeks ago, or maybe months ago, that, traditionally, I think the liquid side of the oil and gas business has always essentially been treated as a batch process. You batch it into tanks, and either you haul it off with a truck or you pump it into a pipeline. And I sense that with these tankless designs, we almost need to move that to more of a continuous process, like you would in a refinery or a chemical plant. And so obviously to do that, it takes automation and it takes some control. So, when you're talking about control valves, you might have to invest in something that has tighter control characteristics and just have better measurement overall to accomplish that. If you're going to continue to try to produce, at the rates that they want to produce.
Yeah, that's an interesting perspective that I hadn't thought about it as a batch moving to continuous, but you're right. That's kind of how it works for the liquids in there.
Right. Mm-hmm.
Let's see. So what are the biggest barriers? Are they technical, financial, regulatory to achieving zero emission well pads? And how can operators realistically overcome these challenges?
Wow, another interesting question. So I would say this, based on our experience, working daily with operators, it is the combination of the three things, right? Technical, financial, and regulatory. So those could be our leverage or could be the barrier. So sometimes, technology moves fast, but technology moving fast comes with a cost. Most of the time that cost goes up all the time, right? So that's one thing. Then regulations is something that we don't control. So we can say something, yes, but it's not up to us to put the final dot into that regulation. So that put that a lot of pressure. And then more specifically, if there is a time and a specific time frame to implement whatever the regulation says. So that put a lot of pressure on the finance at the operators, right? So obviously operators that they have highly productive wells, they can have that return on investment into, trying to comply with this regulation quickly. But those with marginal wells that they produce 10, 20 barrels per day, probably with the time they could be forced to stop producing, right? And that combination, so when you try to solve this, you need to look at the three things. So what is kind of like the realistic approach is case by case, if you will. That's going to be a lot, groups. And there are some groups that is really easy, highly productive wells, then medium, and then it's the small. But I'm going to, go with the case by case situation, because there are different scenarios, and we have seen that several times, not just for this, but Stan, I mean, you have a lot of experience working with them into these things, right?
Yeah, I would agree with all three of those. And then I would add a fourth that I don't know that we call that in the paper, but if you could wrap all three of those in human resources or lack thereof, because, increasingly there's not enough humans to take care of the number of production sites. And I don't think that trend is going to change. I think it's probably going to get more lopsided. And so the way you deal with that, I guess, one way is with automation and being able to automate as much as you can reliably and safely. So I think it almost appears that we're moving into a section of the big guys and the little guys, because we see continued consolidation of the larger ones, and then you have the smaller folks, and those smaller producers, they don't have a lot of people, and so. And as the nature of oil and gas is, it's very distant and spread facilities. So the only way you can do that as a small operator, I think they're going to have to adopt some of these automation strategies to deliver information that's actionable, that they can. They don't have the luxury of just making milk runs to locations just to go there. So they have to manage by exception and. So I think that's important to consider as well.
Yeah, that seems like that will just play to more and more the need for remote operations, and then, being able to go out by exception, which, I think is more coming to land. That's kind of been the mode in offshore production, just because you have these platforms all scattered around and you wanted to try to, do as much as you can remotely and get scramble people out there when needed or something like that. So it's another thing interesting to see more and more, just based on the people side of thing, that coming to onshore
and
production.
Another aspect, that is, you can't just deliver data, because, we can deliver terabytes of data from a field, but you have to be able to contextualize that data and sort through it and just, pick out the meaningful information that someone can take action on. And that's easier said than done. But I think we're making some great strides in that on the software side as well. So
yeah, that's a trend that's coming along to really be able to aid with that and support that. I mentioned this real-time monitoring, and the paper highlights that in data-driven decisions. So how is this whole digital transformation reshaping emissions management in the upstream oil and gas production?
I can think of a real-world example where we have customers that are they're monitoring their separators, for example, on the oil leg of the separator for excursions whenever there's not oil going through the line. I mean, obviously, if everything's working well, then that line should be full of oil all the time. Well, we know that that's not the case, because things do. Mother Nature doesn't cooperate all the time, and you end up with oil and gas or water and gas in the oil legs. And so if you can detect that at the point that it occurs, and if you notify someone, in a timely fashion, you can mitigate not only, the poor measurement, but you mitigate, if it's gas, you mitigate that from going to the tanks and ultimately, having to be recovered or flared. So it's something we've talked about for a long time, the ability to do that. But now I think we're reaching that fruition with the ability to get that data in real time. It's easier to get the data now if you have the right platforms. That's one observation. Manuel?
No, absolutely, 100% agree. That basically said that the digital transformation and the implementation of this industrial Internet of Things basically set the foundation for everything that Stan mentioned already, right? The use of machine learning, artificial intelligence, not just in the cloud, but just at the edge for quick actions and helping them with operations and emissions and reducing costs and just being more operational ready for this.
Yeah, I think the sooner you can spot it, that saves you a lot of time trying to clean it up later and re-separate the water and the oil from each other, or the gas, or, whatever, so earlier is better. Mm-hmm. So how do acoustic transmitters and smart pressure relief valves contribute to proactive maintenance strategies? And I guess what kind of ROI can operators expect from these upgrades?
Yeah, that's a good question. I would say this, and Stan, you jump in at any time, but I would say every portion or every part of the well pad or the well side that is above our head or our height, it is overlooked, right? So we don't like to be all the time just looking up and seeing that, right? So where are the PRVs? Where are the vapor recovery units and all that thing that's going to be on the top of the tank, on the top of the vessels, right? So that's what it is. Most of the time, those are overlooked, and we don't tend to go and verify that really often. So that means is sometimes complicated to detect if the valve really closed well, sit back down into the original position, or still releasing a little bit of pressure that we cannot see or we cannot hear, right? So that's where those acoustic devices help to really identify that portion, because all that gas, it is not just going to the atmosphere. It's not just getting released. It is money that is not going into the sales line. I'm not getting any revenue of that, right? So if I am able to avoid that situation and put that gas into the sales line, so I'm going to make profit out of that, right? So that's basically complement the return of investment. So, Stan, anything you want to add here?
I think you covered that eloquently, Manuel. I don't have anything to add.
Thank you.
Yeah, I would just say, because they are up high and difficult, you may have like a pressure relief valve that's been leaking for 6 months before someone goes and check it. So if you look at all that, it's not just what you're losing revenue wise. I mean, that could be a safety concern. What's, in that area if somebody's, if an operator's going around that area. So yeah, that can really help. Another thing, you spot it right away. It's good for you financially. It's good safety wise to deal with that. So in your view, how can emissions mitigation efforts align with profitability and operational efficiency? I guess especially for the smaller producers.
Wow, that's a tough question, especially as you say for small producers, right? So that needs to be 100% aligned, right? Because those are small producers. Every movement, every investment needs to be really well thinking, and every single movement can put them or on the right side of the path or on the opposite, where they have to be forced to stop production. It's not profitable anymore, right? So it needs to be 100% aligned, needs to understand what the consequences, what the options they have in order to make a movement. Is especially difficult, not difficult, but more challenging for small producers, I would say. And anything else?
Yeah, I would just say, the smaller producers don't have the staff a lot of times for that. So I think they could benefit from some prepackaged solutions or, some engineering or just more simple solutions that are available. And I think, Emerson can certainly help with that.
Yeah, it seems like if you're able to add more sensors to see what's going on to help in those mitigation efforts, it's also kind of setting you up for more remote operations to be able to see what's going on. But it's a challenge just based on people and budgets and all the other things there. I guess let's look ahead a little bit. What emerging technologies or practices do you believe will define the next decade of emission reductions in oil and gas production?
Okay, good question again. You are full of good questions, Jim. Well, honestly, it should be a combination in between technologies and practices. And the reason I'm saying this, I just recently attended a conference where one of the producers were talking about all the new implementations they were doing on the tanks. And they have to make several changes because they didn't change the practices of their operators. So even that they changed from new technologies on top of the tanks from some devices, operators, they were not adjust to that technology. They continue leaving the teach hatches open, right? So basically they have to approach that in a different way. For some of them, they have to remove those devices, those tip hatches. And it's not because the tip hatch itself, it's not because the technology, it was because the practice, it was because educational practices they may have, right? So on the other hand, so we're seeing and we're going to continue seeing, and I'm 100% sure we're coming with several of those new technologies that we're seeing smaller and cheaper sensors, becoming more and more commercial, ready to use in hazardous environments like oil and gas. This combined with the powerful new computing systems, advanced analytics, artificial intelligence, etc. So that will change the practices. That will change the way operators they are going to be able to mitigate, not just monitoring and reporting, just to really look at what is the root cause and go and tackle that and eliminate that source of emissions. So that would help them to become more profitable, but at the same time more sustainable into this matter. That's my view. Stan, do you have any other point here?
I would agree, and I would add that not only on the sensor side, but on the communication side, you're going to see different protocols evolving, LoRaWAN and others, where because there's where we're trending, we're getting more data from everything. I mean, your refrigerator can tell you when you're out of milk. So, these devices are serving more and more data. And, the traditional SCADA systems, it's like pushing a watermelon through a straw. So, just because we can send all the data doesn't mean we should. So I think, we'll be doing more reporting by exception, with MQTT and those kind of protocols where you just report when a variable changes or, report only when you need to. So it reduces the traffic and you're just sending the actionable information. And obviously, you have to operate safely. That's number one priority. And then number two is keep operating. And so I think not only combined with the new sensors, but we're going to have a variety of protocols that are available too. So that'll be hard, or it'll be interesting to see how that evolves. I heard someone say that we'll see as much change in the next 5 years as we have since the Industrial Revolution. I have no idea if that's true, but it sure feels that way.
Yeah. I suspect that may very well be true. And it's like, you're right, there's crushing amounts of data. So you're seeing AI come on the scene to help kind of distill it, make sense of it. And you can see more of that moving to the edge locally, not having to send it all to the cloud in it there. So yeah, I think what we've traditionally seen for decades as far as communicating information and everything else probably will change quite dramatically here over the next couple years. Now, I'll add a link to the white paper for our listeners to get a hold of. Is there anywhere else you'd recommend that they go to learn more about what we can do to help them with emissions?
Absolutely. Emerson.com/oil and gas. So they're going to find that paper, and as well as any other information about the technologies, about the software and devices that we use to eliminate or reduce or mitigate emissions.
Okay, that's great. I'll add a link in the transcript to that as well. And Manuel, Stan, I want to thank you both so much for sharing your expertise in this emissions reduction for oil and gas producers. Thank you so much for joining us today.
Thank you, Jim.
Our pleasure. Yeah, and I would say if there is interest, reach out to us on LinkedIn. I know you can find me and Manuel out there. So if you just want to, get some input, or we'd be happy to open some dialogue with you.
Yeah, I love when they connect with our experts everywhere. So, yep, use that LinkedIn. All right, thank you both. We'll do this again sometime.
Absolutely.
Thanks, Jim.
Thank you.